All right, welcome to our Unit 2, Day 3 lesson on while loops. So this is available via a pair deck as well. Make sure you complete that pair deck so that you get credit for the questions that are in the pair deck. But let's take a minute to look through what we're going to do today. We're going to take a look at applying repeating logic in the programs and evaluate, tell whether or not an if or while block is more appropriate given a situation. We'll do some warm-ups. That's in the pair deck, so make sure you complete those. And then we're going to talk about the lecture. You should have some lab time within class to keep working on it. Again, make sure you complete the honor code activity. That is due today. For the odd classes, it is due on Wednesday the 28th, which is when you're probably watching this video. Unit 2, exercises in the lab. You should be able to start working on those and get those completed before the assessment. If you need to take a Unit 1 retake, make sure you contact me to schedule that as soon as you can. So we see a couple warm-ups here. We'll go ahead and skip through this. These are in your pair deck, so make sure you're answering them. But for now, we're going to skip through that. We will discuss this in class when I have time to talk through it with you all. So the while loop. It is an entry controlled loop. We call it that because there's a block of code in which we control whether or not you're able to enter into that code based on some condition. So we use the keyword while, as you see down here. While this condition is true, if it evaluates as true, then we're able to get into the loop body. And so that's why we call it an entry controlled loop, because the condition controls whether we enter the loop or not. And the slides we're going to be looking at are discussing the continuing condition based on the fact that there are no breaks or continue keywords built into the loop. It's only working based on the continue condition. It does resemble an if, but the main difference between the two is that ifs run exactly 0 or 1 times, whereas a while loop can run an infinite number of times, or possibly 0 times, or somewhere in between there. So this is a typical progression. You can look at this and try to get a feel for how we're going to step trace through this. First, we check the condition to see if it's true or false. If we get a true evaluation, then we're going to execute the entire loop body. Even if in the middle of that body, our condition becomes false, the body will continue to execute until the very end. It's only then where we return back to step 1, where we test the condition after the loop body has finished, that it's going to evaluate as false at that moment, and then we skip the body in any subsequent iterations. So let's take a look at this. We start off with an int value of 0, a num value of 7,842, and our first step here is to evaluate or to check whether or not num is greater than 0. Since it is true that num is greater than 0, we are going to continue to step 2, where we divide num by 10 and then resave that, reassign that to the num value. It will now hold 784. We then increase count to 1, and we return to step 1 to evaluate if 784 is greater than 0. Since that is true, we go into the code body, we enter into the code body, we divide and reassign num to be the result of dividing by 10. So we get 78. Count will increase to 2. And then we're going to return back to step 1, where we evaluate num is greater than 0. It's still true. So we execute again and then return to step 1. It's still true that 7 is greater than 0. So we're going to execute the entire loop body. As you see here, that division made num 0. 0 is no longer greater than 0. Yet, the body will continue all the way to the end. So count plus plus will happen. And now we return to step 1, where 0 evaluates as false when it's compared to greater than 0. Since that's false, we're going to skip this loop body, and we will then just outprint count, which gives us 4, which is the current value of count. So let's take a look at a set of code that examines how the old honor code assessment used to be operated. In this situation, there were 30 multiple choice questions, and you had to get all 30 correct in order to pass and progress and be finished with the assessment. But you could take it as many times as you wanted. That was part of the warm-up exercises, so hopefully you understand where this is coming from. So you can see how this might get set up. We prompt the user to answer how many questions they got correct. We declare a variable num correct and assign it to be the next integer. Then we check. While num correct is not 30, then we're going to tell them to try again until they get 30 correct. We prompt them again to enter how many they got correct and record their choice, their entry. And that's important because you have to provide them with the ability to provide you a new value for that variable so that this while loop can eventually end. And if once that's done, they get 30 correct, that's when we're going to get this congratulations, you're finished. But that only prints after the loop is over because it's outside of this loop body. So you'll be able to answer this. And now what we're going to look at here is a do while loop. This is what we're going to call an exit controlled loop. It's exit controlled because the body will always run at least one time. So there's no condition to enter into the loop body, but after the loop body is run one time, we check the condition to see if we need to end it or not. And once it's run once, the condition is evaluated as true or false. If it's false, then that's it. We just move on to the next line of code below it. But if it evaluates as true, we go back to the top of the code body and we run it again. And then we check the condition again. So that's why we call it an exit controlled, because what is being controlled is whether or not the loop body exits, not whether or not we enter it. Now, this is not a part of APCSA, meaning it's not going to be on your AP exam, but it's still important. It's still worth knowing. It's a very useful technique, and you will see it commonly within code. And so let's just take a look at what that would look like. So here you see int x equals 10. What I want you to do is this code body. So I use the keyword do. So it's going to execute. So we see x increases by 10 or by 1 from 10 to give me 11. It prints 11. Then it checks. Is 11 greater than 15? That's false. So the loop ends and it prints all done. So you see, in the beginning, 10 was never greater than 15. X was never greater than 15, yet it still ran the code body at least one time. If this had evaluated as true, it would have continued to keep running again. So here's another one, how we might want to set up our honor code assessment with a do while loop. We create a variable, number correct. We give it an initial value so that it's initialized. Sometimes we get errors with variables when you try to initialize it within some kind of code structure. Then you can sometimes have trouble because there's no initialized value. So we start off by initializing our number correct to 0. And then we come in and we give it a value later on, which is going to be the actual value that's evaluated at that time. So we prompt them how many questions you get correct. We record their answer. We check if it's 30 or not. If it's not 30, we tell them to do it again. And then it's, of course, going to evaluate as false again here. So then it loops back up, asks them how many they got correct, and gives them a chance to change it again. So make sure you understand how this is working. If you have questions, we can talk about it next time I'm in class. And here's an infinite while loop, something that you need to be careful about as you are writing these loops. Because if you write a loop based on some variable, such as number correct not being 30, if you never give them a way for that loop to end, then it's going to continuously run and run and run and run, and theoretically would never stop. You would have to force it to end some way. And so as you see here, it's based on number correct. I'm asking them to re-enter the value, but I never give them that choice. I never give them a num correct equals input dot next int as a mistake. And so this is what I'm going to see over and over and over and over again. I will never see congratulations, you're finished, unfortunately. Here's another example of an infinite loop. In this case, I did change the value of the variable that it's conditioned on. Last slide, we didn't provide a way to change num correct. Here, x is changing. It's going down, but it's going in the wrong direction. 10, 9, 8, 7, 6. I'm never going to be less than 20 going that way. So this loop will never end. It's just going to give me a new number forever and ever and ever until it gets to integer min val. All right, and then it'll loop after a very long delay. All right, so take a break and then we'll get started again here talking about, we're almost done here. We're talking about some practical uses for while loops. Where would you see this in your code? And one option is a run again option. And that's where we have some set of code, like a program that's running. And when it's over, perhaps you want to provide your user with the option to just continue to do it all over again. Instead of having to restart the program, you could just provide them with a run again option where they have the ability to say, no, I don't want to run again, or yes, I do want to run again. So make sure you give them a way to get out and a way to start over, as you can see here. So here's what that might look like. Let's say we had a program where we wanted to square a number. And I've told them to enter a number to be squared and press 0 to exit. So that allows them to enter a number, and then while that number is not 0, then it's going to square the number, tell me what the result was, and then prompt me to enter a new number again and check whether or not it's a 0 or not. And once somebody does enter 0, I will get a goodbye. And here's one of those keywords we talked about before. All of these while loops have been predicated on the loop having some variable that I can change so that at some point the while condition evaluates to false. But under that situation, it always has to wait until it gets back to the while condition. So there's no way to stop the loop body when it was in the middle of executing. But the break statement provides us with the ability to immediately end a loop. As soon as it gets to a break statement, the loop will end. And we'll take a look at that in a minute, but keep in mind that the break statement does not work under an if condition. Please keep that in mind. So here's a run again option using a break statement. Now this is a little bit dangerous here because this condition is set to the constant value of true. Since it's a constant value, it's never going to change. So this condition will always evaluate as true. So the way it's set up here, it appears to be an infinite loop because there's no variable to change. True is always true. So it appears that we're going to have an issue here that we would never get to goodbye. But if we look into the code, we see that if num ever equals 0, then this line of code here, break, will run. And as soon as it hits break, the code is over. It will not ask me to put in another result, another value. Break ends it. And notice it's just one line of code, just one word, break, semicolon. Oh, let me go back. That was a little too fast. So that way you can take a look at this and see what's going on. So here's the other way we could use a while loop, and this is called an error checking. Error checking is when you're trying to kind of delay the program from going forward until the user performs some action correctly. So this could be a number of different things you might want to be error checking for. For this unit, we're going to kind of focus in here on checking to make sure that the numbers that they entered fall within an appropriate range. Not too big, not too little. And if the user enters a number that's not appropriate for the program, we're going to catch it in the while loop, prompt them to redo it, and if they try to do it again, it's going to prompt them again, and it won't let them out until they've done it correctly. So here's an example of this. Asking for a numerator, record it. Asking for a denominator, record it. Then we have a while loop set up to check whether or not it's 0. If it is 0, well then we're going to tell them that they can't divide by 0. Give them a chance to enter a new denominator and then check it again. Make sure that they did it correctly the second time. If not, it's going to prompt them a third time. And it's going to keep prompting them until they give me a number that's not equal to 0, at which case it will then move forward in the program and allow them to do the division that they wanted to do. And there's a little bit of breakdown for you on how that is structured. And that's it for today. You'll have a chance to kind of position how you felt about the lesson in that pair deck. And if you have questions, please don't hesitate to reach out to me and let me know. Otherwise, I will see you in class